Hello everyone, today we are going to see mass transfer, right? So first of all, what is mean by mass transfer? Mass transfer is nothing but the process of transfer of mass from one region to another region, right? So this mass transfer happens when there is a concentration difference, okay? There are two species like these two. I am making a cup like this and I am placing a membrane here, and here one liquid is filled and here another liquid is filled, right? So if I filled two liquids with two different concentrations, for example this is at high concentration, this is at low concentration, the mass will transferred from high concentration region to low concentration region because of the species concentration difference. This is called as mass transfer. This mass transfer will be occurred in daily life. First one, we can say in a cup of tea the sugar is dissolved, right? That is the perfect example for mass transfer. Second thing, when you are filling the petrol for your bike in petrol bag, you can realize the smell of the petrol, right? So that is because of the mass transfer, that is evaporation of petrol is happening there, right? So similarly, dissolving of smoke in the air, humidification of air in cooling tower, right? So this mass transfer happens in two modes. First one is diffusion mass transfer, second one is convective mass transfer, right? So we will see what is diffusion mass transfer and convective mass transfer in later. Now the diffusion mass transfer can be classified into two categories. One is molecular diffusion, second one is eddy diffusion. We will see the definition for molecular diffusion and eddy diffusion. The molecular diffusion is nothing but the transport of water itself, right? So I am having a flask here and another flask here. I am connecting these two flasks with the thin tube, right? So the water itself, because of the concentration difference, the water itself transferred through this tube to here, right? From here the water is transferred through this tube to here because of the water itself transferred at a microscopic level at a result of diffusion from higher concentration region to lower concentration region in a mixture of liquid or gases, whatever the state it is known as molecular diffusion. So molecular diffusion is nothing but the water molecule itself microscopically transferred from one region to another region, right? So next thing is eddy diffusion. When one of the diffusion fluids, there are two fluids, when one of the fluid is in turbulent motion, the eddy diffusion takes place. So mass transfer is more rapid in eddy diffusion rather than the molecular diffusion. The next thing we have to go for convective mass transfer. Convective mass transfer is nothing but it is a process of mass transfer that will occur between a surface and fluid motion. We are drying the cloth in our home, no? That is a perfect example for convective mass transfer. Now after convective mass transfer, we are going to see some terminology in mass transfer and then we will solve the problems on those things, right? So the first thing is mass concentration or mass density, right? So consider I am filling a liquid, I am filling a mixer of liquid, right? It may be anything, water or solid water. For example, air is combined of oxygen, nitrogen and other gases, right? That is a mixture of different gases forms air, right? I'm filling 1 meter cube of tank with air, right? Now consider that the mass of the air is 1 kg. The mass of the air is 1 kg, right? Now the volume of the container is 1 meter cube. If in 1 meter cube of volume 1 kilogram of air is filled, then mass concentration is 1 kg divided by 1 meter cube, which is equal to 1 kilogram per meter cube. This is the mass concentration value of air, right? Next thing is molar concentration or molar density, right? So molar concentration is defined as the number of molecules. In the last definition we have seen the kilogram, that is the weight of the molecule. Here weight of the component, here we are seeing number of molecules per unit volume of mixer, right? So similarly, if I take 1 meter cube of container, I filled the air within the container and I am counting the number of molecules. If the number of molecule is 500, then 500 number of molecules divided by, this is kg per kg mole divided by meter cube is the 500 kg mole divided by meter cube is the molar concentration. Okay, so the mass concentration and the molar concentration are related by the expression Ca equal to rho A divided by number of molecular weight of component, right? So Ca is nothing but your molar concentration of a component A. Consider a mixer is having the component A, B, C. Here I am considering only the component A, right? So the molar concentration Ca is equal to mass concentration of the component A, rho A divided by Ma. Ma is nothing but molecular weight of the component A, right? So if I am consider hydrogen as a molecule and Ma is equal to 1. Similarly, you can choose the molecular weight from the data book itself for different components. Similarly, I told you, no, the mixer considers of the mixer have the component A, component B, component C. Similarly, the same equation can be written as Cb equal to rho B divided by Mb. Similarly, Cc equal to rho C divided by Mc. For the mixer, it is C equal to rho divided by M. Okay. Next thing is mass fraction. Mass fraction is defined as the mass concentration of each component to the total mass density of the mixer, right? So this is small m of A equal to mass concentration of the species rho of A divided by total mass density, that is rho. So rho is nothing but, as I already told you, if the mixer has A, B, C, 3 components, rho A plus rho B plus rho C, right? So density equal to, so mass density equal to rho A plus rho B plus rho C. Similarly, this can be written as for Mb equal to rho B divided by rho. Okay. Next thing is mole fraction. Mole fraction is defined as the ratio of mole concentration of a species to the total molecular concentration, that is X A equal to Ca divided by total C, right? So next thing, very important thing, in heat transfer you have seen the, you know the Fourier's formula, that is Q by A is directly proportional to dt divided by dx. Here instead of Q I am having Ma, that is molar flux Ma divided by per unit area is directly proportional to, here I am writing temperature gradient because the heat transfer happens because of the temperature difference. Here the mass transfer happens because of the concentration difference. So I am here putting concentration gradient. So Ma divided by capital A per unit area is directly proportional to the concentration difference, right? Concentration gradient. This proportionality constant has to be removed. Here we introduce thermal conductivity K, but here we are going to introduce DAB, that is diffusion coefficient between component A to B, right? So that is the constant we are introducing here. So Ma divided by A equal to, here we put minus, no, the same minus should become here, minus DAB into concentration gradient. This Ma divided by A can be written as molar flux, Na, like this. Okay, this is diffusion coefficient. This diffusion coefficient value can be taken from the heat and mass transfer data book by the given component, right? Okay, next thing is analogy between heat and mass transfer, right? So what is this is means there will be lot of similarity between heat transfer and mass transfer. That is why we are studying heat and mass transfer simultaneously, right? So the formulas, once you know the formulas and concepts for the heat transfer, then mass transfer will be very easy for you, right? So that is the analogy between heat and mass transfer. In heat transfer, we are worrying about the temperature, where in mass transfer, we are worrying about the concentration difference, right? So heat transfer happens because of the temperature difference, whereas the mass transfer happens because of the concentration difference. That is one similarity. Second one is heat transfer takes place by three modes, conduction, convection, radiation. Similarly, mass transfer happens by two modes. One is diffusion mass transfer, second one is convective mass transfer. You can compare this conduction and diffusion, right? So these are similar phenomenons. As I already told you, the conduction takes place because of Fourier's law of conduction. That is, diffusion takes place because of Fick's law of diffusion, right? So these two similarities are the analogy between heat and mass transfer. Similarly, the convective mass transfer and the heat convection will have similar way of approach, similar concept, right? So these two has to be studied simultaneously. That is why we are studying heat and mass transfer as this subject. Okay, thank you all. In the next video, we will solve some problems with these concepts.